Hi, friends. Welcome again to another episode of Beyond the Clouds Edge to Edge Transformation. And when I think about it, for me, the edge started with the wafers. When I was doing wafer probing, testing on the test floor at Intel during the Pentium days. And we've come a long way since then. Those days, PCs were still esoteric. Few people had them. Today, every single machine has some chip or the other, and soon our bodies may have it too. And here's with us Robert Quinn. He also worked on some very interesting things. Robert, tell us about your journey. How did you become the Robert Quinn we know today?
How you doing today? I started my journey in 1997 at Applied Materials. I started working on the manufacturing line and I worked my way through into chamber test and then into final test and many platforms at Applied Materials. And then I found my way into field engineering and traveled the world as a field engineer, working on all the different fabs around the world. I've worked on just about every platform that Applied Materials had, a lot of different production lines and doing a lot of startups and a lot of deinstalls and other maintenance working on the tools. So great career working for 25 years in the semiconductor industry with a very broad view of the full ecosystem of where it begins and ends. Understanding that in full is really important. A lot of people don't understand the apples and oranges of this industry and what the difference is in this ecosystem and understanding the different concepts. I was talking to a group at the country of Poland, and they said they wanted to bring the semiconductor industry ecosystem to Poland. They wanted to start with EUV. I was like, okay, number one, we have to teach you about what is EUV and what is legacy and what is different. You need to understand the concepts here and the very big differences in pricing between a $40 billion fab and a $10 million fab. Like, big differences. It's really critical for people to understand that ecosystem and how this industry operates. It's been a great career. I've loved working in the semiconductor industry, working on the equipment. I've recently done some speaking in different events. I was recently in Brazil. I got my Brazilian shirt here at the University of Sao Paulo, speaking about the semiconductor industry ecosystem and where South America and Brazil can really get a bigger footprint in that ecosystem. I was also recently in Oman, speaking in an event with the royal family in the ministry. That was a great experience. Being able to travel around and meet new people and experience the understanding like how different terminologies whenever you're speaking to somebody like the royal family, you have to understand that you can't speak tech to them. You can't speak like I'm talking to you. You and I could jabber on and talk about PVD, CVD, ALD, and all these different acronyms within the industry, but you have to understand that a lot of these people, they don't understand that language. And you have to learn how to speak two languages, really, because you have to learn how to speak the language of tech, but at the same time, you have to dumb it down to where it's understandable for most people, at the same time not making them feel like a child that they don't understand, at the same time making them feel smart enough that they can understand. And to speak about this industry and where we are and where we're going and how this ecosystem is morphing around the world. It's incredible the change that we've seen in the last 10 years. I just can't get over it.
So, Robert, you are one of the first people I listen to on LinkedIn in the mornings. My knowledge is in high level design, design automation, and cadence, synopsis, you name it, and also the whole process leading up to silicon to systems and AI. You help me understand the substratum, the whole basis of the industry. And what an amazing thing that you started off literally working on wafers and chips and the equipment that is used to make all this happen. How did you end up becoming a blogger? Because that's a different set of skills, isn't it?
Very different. Very different. So I started, what was it? I was about 2013. I was working at Samsung and I realized I had about two people ahead of me that were career Samsung employees. I wanted to get into management. They wanted to get into management. And I said, well, I'm going to be here for the rest of my life until I'm 90, waiting for these people to die so I can actually get into a management role. That's when I left and I went into working for a company called Retronics here in Austin. I became the operations manager for Retronics. And that was a time that I saw a video. I was working in operations. Retronics did refurbishment, decontamination of semiconductor equipment, and we did a lot of different aspects of the industry. Part of my role was to read the news and to see what was going on in the industry and see where we could grow as a business. I saw a video. This guy named Gary Vaynerchuk on YouTube. He's a internet guru, has millions of followers on YouTube and also on LinkedIn. He said, do something for others, ask for nothing in return. And I said, okay, I'll accept this challenge. So I was like, well, part of my day, anyways, is to just read the news, to write about what's going on, to talk about what's going on in the industry. I'll just rewrite what I read about on the LinkedIn. And so I started writing on LinkedIn and kind of curating content and putting information out there that I was reading about on LinkedIn. Next thing I know, I'm receiving phone calls from directors of billion-dollar firms, and they're, wow, I love your content. Thanks for writing this. I appreciate it. And it just grew and grew. Before I know it, I'm adding 100 followers a day. Today, I'm at 47,000 followers. It's just grown expansively. People are hungry for the news and to learn about the semiconductor industry. Chips in the last 3 years or so have become a part of people's vocabulary. The word semiconductor has become a part of people's vocabulary in the last 3 years. I would tell people that I work in semiconductor, and people would just be like, okay, didn't know what that meant. And now people know what semiconductors are because they notice the bedrock of all the foundation of technology that's coming towards us in the near future and that we utilize today. I think still people are trying to figure out, they realize a semiconductor is a chip. They don't really realize more than that.
Yeah, very true. I mean, I started during the Pentium days, and the only thing people knew was the Intel Inside symbol, but not more than that. Then you talk about applied materials or cadence, that's a lot more confusing. But one question I have, the amount of information today is just crazy, right? Because silicon has become a craze, and we've got the siliconomy, and we got billions put in by the governments. In fact, I was talking to somebody in India, and he was a diamond trader. I was like, can I somehow use diamonds in the semiconductor industry? Like, why would you want to do that? Well, because the government is putting $20 billion. Maybe I can get a few million out of it. There's this insane drive. How are you able to simplify all this huge amount of information and convey in bite-sized chunks something that's so meaningful that many of us look forward to your blog every day? What's your magic?
I read a lot, and I spend a lot of my time just kind of reviewing topics. I go to Google News, I go to LinkedIn. I have different methods of sifting through international blogs and international news sources because I don't want it to be geocentric to just one region of the world. I want to see what France is saying. If I can't translate it in the article itself, I'll take the whole article and I'll pop it into ChatGPT, knowing that it's a semiconductor article. I want to see what their view is and how they sense it because geopolitically things are so different. People see things so differently around the world, and you don't realize what that truth really is, right? It's one of the problems with AI right now is artificial intelligence is what is truth, right? Like I was in Brazil, we're driving through the favelas of Brazil, like where those shanty towns are, and I pointed to the community and I said, oh look, there's the favelas, and the guy goes, no, this is not favela, this is a community. And I said, it's a favela. I don't care what you say. They have machine guns in there. It's a favela. Like, and the guy's like, no, no, this is a community now. We don't call them favelas anymore. And so what's truth, right? His truth is it's a community. My truth is it's a favela. Like, and so what is truth anymore? How do you deal with that, right? It's so perspective on the geopolitics and the views of people regionally and how they view things. So I want to make sure that I'm getting my news sources from different regions of the world and trying to figure out how I can see what their view is and what do they think about this as a country. It's good to not put yourself in a box and try to see it from other people's perspectives. Despite he thinks that way, I think this way, we'll agree to disagree. But I still enjoy hearing his perspective on it. That really made me think a lot about AI and artificial intelligence and what is truth and how do we train artificial intelligence about truth. How do you take that perspective and say what is right, what is wrong? Well, it's different regionally. It's, what is, my gosh, you say what is conservative dress in Rio de Janeiro? Well, it's a thong and a bikini. Oh, you go to Oman or Dubai and it's a whole lot more clothes than a thong and a bikini, right? It's very different regionally about how people perceive things and how they see things. And it's not just with that, but it's with business and everything.
3 years ago, during the pandemic, the supply chain was completely strained. Today, you've got more geopolitics, you've got trade wars. Are we at a point where we will have good supply chains?
Supply chains are apples and oranges. They're a little bit different depending on what type of product you're trying to produce. Are you trying to produce a 3 nanometer chip that goes into a phone? Or are you trying to produce a 256 nanometer chip that goes into your transmission or into your dishwasher? Supply chains for the 256 nanometer legacy technology is definitely coming up to speed globally around the world. We're producing a lot here in the US. We're producing it in Asia. We're going to see good supply chains for the old technology. What the United States is currently trying to do is to harness the 3 nanometer EUV technology. And this is the technology that is going to take us forward into the AI, artificial intelligence, and soon to be AGI, artificial generative intelligence, where we're going to see the NVIDIA H100 GPU is made in TSMC. I believe it's done on 7 nanometer technology or below, but it is advanced technology. You have to have the EUV equipment to be able to manufacture this type of technology. Currently, we're not going to permit it to go to China. We will continue to see lots of the so-called chip wars happening, nations fighting back and forth on who gets to harness this technology. This is going to be a big driver. The reason why we're seeing Ohio, Austin, Arizona, Oregon, Micron, New York. Like, we've got about $100 billion of fabs going up in the United States right now. They're building 2 TSMCs. They're building Samsung here in Austin. They're building another big Intel fab in Ohio. Oregon is doing some expansion. Micron's doing expansion, more expansion in New York. Lots and lots of expansion. We are going to be producing a lot of the EUV technology here in the United States very soon. It's all being produced right now in Taiwan. So you can imagine 90% of the world's technology is dependent on this little island to produce EUV technology. This isn't good. We have to diversify. We're also going to see a lot more EUV expansion in the EU as well. Munich, Ireland just opened up an EUV fab. There is this chip wars happening. We are seeing these competition between nations going on. That's going to continue to get stronger and stronger. The technology is going to go parabolic. So I'm really excited to see what's going to happen there.
I know I've never seen it so good. The silicon economy has become very real. It's been a cyclic industry for quite a while. So there's always this boom and the bust cycle. Right now, we seem to be investing so much, 100 billion in the US alone, and probably similar numbers in EU. Are we going to end up with a glut? Or are there enough use cases that we will need all these chips? And would we find new use cases going forward?
Yes, there's going to be an excess amount of chips for a temporary amount of time. If you take the growth rate of chip demand and you compound it by the expansive growth of technology, we're going to have chips in everything. You and I talked about this earlier. Like, just there's just going to be chips in everything in the future. These chip foundries are going to find themselves 10 years from now saying, oh, we need to expand again. If I were to make a guess, I would say yes, we're going to see a lot of fabs go up. Yes, we're going to see a little bit of a glut of chips being produced for a couple of years. 10 years from now, they're going to say, we need more chips. Let's expand again. This is the industry. We've been through it for the last 25 years together. This is how this industry works. We work on all in or all out. I never forget one of the companies I worked for. They went through a layoff. We had 168 people in the company. They left 6. And everybody else, nice to know you. There's the door. That's the way it's worked for the last 25 years. And we see these ups and these downs, and there's just so vertical, and there's so much demand here, and there's so much, let go here.
Interestingly, you and I use ChatGPT almost every day. It helps us to get information, sift through it. How do you make sure, especially when you're working on publications in other languages from around the world, that they don't hallucinate too much, that they give you useful information? And how do you make sure that your voice is heard? Every time I read your stuff, it has the Robert Quinn stamp on it. How do you make sure of that?
Just using the tools so that you can translate the information, make sure that you're understanding what it's saying. Obviously, if you see things that are wild, outrageous things, you're like, let me look into that and check that again. I actually threw a mathematical equation into ChatGPT. It gave me an answer, and I said, no, that's not right. Like, that's not right. And I went into a calculator on my phone and I did it. And I said, sure enough, it was hallucinating, throwing out wrong numbers. You can't always trust it. As far as a translator, I think they work great as translators. There's a lot of other uses for it as well, and we'll continue to see lots of growth in that sector. ChatGPT and Bard. I'll look for a word. I'll be like, what's the word I'm looking for? How do I say this? And so Bard and ChatGPT and other sources, they're great for all that. We'll continue to see lots of growth in that sector. I'm surprised. I did do a poll on my LinkedIn. I asked what percentage of people are using AI in their daily jobs. It was actually pretty low. It was like 38% or something like that. I thought that was fairly low considering I thought that everybody was using it, but I still meet people today that don't know what ChatGPT is.
There's a lot of healthy and unhealthy skepticism about what they can and cannot be used. You were in the trenches like me at one time, and we were doing real hardcore engineering work. And now you're on the other side, telling stories about engineering, telling stories about what's going on, and helping even executives to grasp what's going on. In what ways has that changed your life? Are you the same Robert Quinn who used to work in the trenches?
I think so. I'm the same person. I've just always been that person that enjoyed talking to people. One of the things I loved about working in the fab was usually they would pair us up in partnerships with two people, just be you and another engineer or another tech working on the floor and on a piece of equipment. You get to know somebody really, really well, 12 hours in the fab working side by side together. And just being able to talk to people and being able to meet people. My wife always calls me the social butterfly. I seem to be able to talk to people and get to know people. I've always been kind of that person. I still try to be that person whenever I'm at work or whenever I'm writing. Think about people more than anything. We all have our difficult times, but we all go through hard times together as well. I've worked with people that were very opposite thinkers of me, yet we found common ground together and we spent years together working side by side. I've enjoyed those friendships and working with those people. It's been good. I like to see other people's point of view. My recent trip to Oman, I was actually asked to go speak for the royal family in the Ministry of Oman. And one of my stipulations was like, I'll go in one condition. I got to go to Dubai for about 3 days. Dubai was my bucket list, right? I had to go to Dubai to go visit. But I went to Oman. It just blew my mind. Wow, this opposite end of the world. It was just so opposite of what I even imagined. Yes, we kind of see things very differently, and we have different religions, and we have different cultures, and we have different ways of doing things. But like, wow, how cool is that? I just bonded with some people so close out there. It was just amazing being able to talk to people and have deep conversations with them. I really enjoyed it. And of course, talking about tech and semiconductor and everything else as well. It was good.
Yeah, when I first came to the United States, I felt the same way. It was the exact opposite side of the world, and it was very different. A lot of people are phobic when it comes to technology. Right now, the demand for engineers seems to be at an all time high, especially as all these fabs come on board. And there'll also be a demand for AI technologies and software and all that stuff. But there's a lot of phobia around technology. What advice do you give? You started off literally in the trenches. How should people approach technology, and what are the ways in which they can get immersed in it and use it and build it?
So, one of the topics you and I were talking about earlier is about the staffing of the semiconductor industry and how critical this is. Last year, I started a nonprofit organization. I had this idea that as an engineer in the semiconductor fab, I was always the guy that brought in the new college graduates to the fabs. They go into the gowning room, you put your suit on, and you walk into the fab. If they weren't wearing a mask and this is all you could see of their face, you would see their jaw going like this because it is just awe to walk into these billion-dollar facilities. You have 500 robots flying over your head. You have all this equipment that the fab is humming like a train engine. It is just, you feel like you stepped into a time warp walking into these billion-dollar facilities. They're absolutely amazing. And from day one that I started bringing in these new college graduates into the fabs and doing introductions and showing them these landscapes, I've always thought to myself, gosh, if we could just give this experience to kids, we would have people beating down our door to come work in the semiconductor industry because this is the coolest experience in the world. You just feel like you stepped into a time machine or a spaceship. It's absolutely incredible to experience these facilities. So, with that thought, I thought, well, I'm going to start a nonprofit organization that is going to build 1,000 square foot semi 18 wheeler that expands to 1,000 square feet. You pull this 18 wheeler up to middle schools and high schools around the nation. You expand the walls. You tour 700 students a day through this unit. And you give them a Disney World experience where they like, aha, I learned what semiconductors are today. And so you give this experience to them, and it allows them to really feel and understand and have the excitement to be able to come into the semiconductor industry. I also like to talk to these kids. We haven't raised the funding for the unit yet, but I am taking high school kids to like the JJ Pickle Lab at University of Texas to get these kids excited about the semiconductor industry. You have to be able to speak to them in the terms of saying, hey, listen, we're working on equipment that pumps down to a vacuum of 10 e to the negative 9 torr. What does that mean? That means deep space vacuum. We're injecting a plasma that's as hot as the surface of the sun. We're exciting the molecules and the atoms inside of these chambers, and we're being able to do processes like atomic layer deposition, physical vapor deposition, chemical vapor deposition, and we're now making transistors at 3 nanometers. What does that mean? That means 21 atoms. We're stacking 21 atoms to make transistors today. I have a chip here. This is the Cerebus chip.
Oh, the giant chip. Yeah.
It's 2.6 trillion transistors and 850,000 cores.
Oh, it's like a mirror. I can see my face in it.
What does 2.6 trillion transistors mean? Okay, let's count to a trillion. 1, 2, 3, 4. How long do you think we're going to be here? We'll be here for
Days.
31,000 years, counting to a trillion. That's how big that number is. That number is so exponential that people can't even fathom how big that number is. How this technology, to think that we've gone from a transistor tube that was a single transistor to 2.6 trillion transistors on a single chip. Like, this is crazy, crazy technology, right? Getting them excited about it, teaching them about how to understand it. It's fun. I enjoy talking to the kids and giving them that perspective of the industry. It's important to also do that for not just the kids, but for everybody in the world. They have to be able to understand, what is this technology? Why is it so important? The expansive growth that we've gone from a transistor tube in 74 years. We've gone from a transistor tube to 2.6 trillion transistors on a single chip. That's an insane amount of growth. And that goes parabolic from here, right? In the next 30 to 50 years, I think we'll see the last 200 years of technological expansion. It's absolutely mind-boggling.
Gordon Moore would be so proud to see those mega chips, 2.6 trillion. He
Yeah,
predicted it thanks to the Moore's law many,
yeah,
many years ago, and I had the fortune to meet him when
yeah.
I first worked at Intel during the Pentium days, and to actually see his office 2 years ago when I
Okay.
worked at the Intel Foundry headquarters building. That reminds me, now we are approaching literally molecular or even distances in angstroms. So the chips itself won't get much denser, but we have chiplets and all that stuff. So you think that we will continue the expansion, creating more and more chips in terms of the densities and all that?
The densities, I mean, of course, we'll go from 3 nanometers to 1 nanometer, right? But then we change things like the architecture. We'd be able to start doing 2D packaging, 3D packaging, chiplets, neuromorphic computing, different types of designs. We'll see a lot more of that type of change in the future. Of course, it's hard to say how we're going to go below 1 nanometer, right? But the other forms of transistor density will change. Since we're going to have chiplets, you can say transistor density per unit or computing power density per unit. It would change that wording a little bit more in that sense. I think that Gordon Moore's view of every 2 years will be amplified a lot more in the next 10 years. We'll continue to see lots of growth in that area. But it will be through different forms, neuromorphic computing, quantum computing. Right? Oh my gosh, the quantum computing just changes everything. That chip that I just showed you is an AI supercomputer chip. You get a chip in a server, and I believe that server unit goes for about $2 million or so. Undoubtedly, we'll continue to see lots of growth there.
It's funny. Every time there's growth, we say, oh, maybe now it's the end of the growth. And there you go again. It's been going on like that ever since I started in the industry. With all this technology coming on board, there's also the fear that humans will have nothing to do. What's your take on that?
It'll be interesting to watch to see the changes. If you think about it, financially speaking, right? You're running a company. You have an artificial intelligence or AGI type of swarm that are able to produce things like risk management. And so you have a risk management swarm that of AGIs that are able to computationally produce any type of data that a risk manager would be able to produce. How do you say that, okay, I'm going to pay this risk manager $100,000 a year, or I'm going to spend $10,000 a year on investing in this new AI that's going to do it? Of course, you're going to replace him with the new AI technology. But at the same time, that one job leaves, a new job does come in, it seems like a lot of times. You will see a lot more technicians, right? We're going to need mass amounts of technicians to be able to keep up with all these equipment. I was reading the other day, Samsung is looking at getting into making their fabs fully automated, 0 people working at them. And I was like, that will never, ever happen. You will always need people to work in the fabs with the current equipment that we have. Now, if you wanted to change the whole equipment set and all the billions of dollars of equipment inside these fabs, sure, you could set it up so it would be easily handled by automation and robotics, whatnot. But to be able to do it without humans right now at this point, I dare somebody to try to train a robot to be able to change an LFM on a CVD. It's just not possible. You have to get back in places and do things with such fine tuning. It would be very, very difficult to do with robotics. But yes, when we see jobs changing, one of the jobs I saw the other day that really caught my interest was pathology. With automation and AI, we might see pathology totally automated. Like, why would you see a pathologist if AI can do everything? Now we have systems that artificial intelligence can determine what type of cancer things are and what, the job of a pathologist really right now. There's a lot of jobs that will change that away. But will we see all of our jobs? No, of course not. Will we see people having to shift between jobs? Maybe you're a risk manager, maybe you need to be a technician now, or you need to be an engineer. Yeah, it's part of change, and we'll see a lot of change in the next 30 years. I can promise you that.
And when we look at our last 30 years, so much has changed. So you started off in the trenches, you've done all kinds of things, you've traveled around the world. Now you write stuff that many of us, tens of thousands of people read almost every day. What next? Where do you see yourself going, Robert?
I've actually got a big thing coming up here in the near future. By the time this is released, I'm actually going to be changing roles. I will be working with International Semiconductor Executive Summit, and I will be leading the summit for the United States. And we'll have a power summit, and we will have another big summit in Arizona. I'm super excited about doing this and moving into this role in the near future.
Wow. Oh,
So,
I'm really happy for you. This is exciting. This is a great surprise, and I'm really happy for you. And there's a real need for it
mhm.
because as we move into this economy in a big way, it means we'll have to wake people up, help them understand what's going on, help educate each other so that we can use. It's not just creating technology, it has to be used in a meaningful way. So this is the reason I talk to people. I actually listen to people. I learn a lot, and nobody can pinpoint where the future is accurately. But what we know is that the world as we see it today will be very different 10,
Yeah.
20, 30 years from now. We all have an obligation to learn with each other, to support each other, and create a world that we can live in that'll be more fun, more useful, more peaceful. So please come forward. I would love to hear from you. And Robert, it's a joy talking to you. Thank you for making the time, and all power to you. You're doing some amazing work.
Thanks so
So
much.
please stay in touch. And when you're back in the Silicon Valley, drop by. Let's meet face to face again.
Love to.